This is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see about the methods of manufacturing of composites. So means how to manufacture the composites. So for that different method. So we will see that lecture topics will be initial form of constituent material, that whatever the constituents we can use. Then next layup method we will see. Then we will see the curing method. Then strength and stiffness advantages. Then cost advantages and weight advantages. So this topic we will see in this video. Right. So let's start with the initial form of constituent material. So in which form that we can use that constituent material, whatever is there, just like I given the roof example. So their constituent materials are what? That is cement, sand, those stones. These are the constituent, and in that you can say that iron rod also. So whatever the things through which we can make anything, that are the constituent. Okay, just like if suppose we have to make chapati. So in chapati, what is required? That atta is required, water is required. So atta and water is the constituent of chapati. Without water, we cannot make chapati from the atta. Or if only we have water, we don't have flour or atta, then we cannot make chapati. So whatever the things we will combine to form something, that is called their constituent. Okay, the fiber and matrix material can be obtained commercially in a variety of form, both individually and as laminate. Laminate is just laminate is one, and combination of the laminate is called laminate. Okay, fibers are available individually or as roving, which is continuous bundle but not twisted group of fiber. Already we had seen that can be up to 600 to 1000 in one toe, right? So that same here, that should be what? Straight. It should not bundle. That means bundle but not twisted. All should be into that bundle only, but not twisted. That must be straight. Okay, so the fiber can be unidirectional or interwoven. Already we had seen interwoven means that should be in the cross link type, that are also, or they must have in same direction. Fibers are often saturated or coated with resinous materials such as epoxy. So resinous material, what we can use, that also can be combined. Fibers can be combined with resinous material. What is that? That epoxy, which is subsequently used as a matrix material. So here epoxy, or that you can say what? That resin is also, we can say that is the matrix only. So what we can add with the fiber or that reinforced material, that is the what? Matrix. So here resin also we can say that is matrix. So which resin we are using? That is epoxy. Okay, the process is referred to as pre-impregnation, and such form of pre-impregnated fibers are called pre-pregs. So before this, what happened? Whatever is the first pre-impregnated, we have to miss first. We have to mark there, miss where and how much that is there. Oh, this is the fiber, just like so. First, that is called the pre-impregnation, and after pre-impregnation, what happened? That whatever is there, that fiber is called as pre-pregs. For example, unidirectional fiber is an epoxy matrix are available in a tape form. So in market some tapes are available, right? So that is there, pre-preg tape, where the fibers run in the lengthwise direction on the tape. So what happened? Some tape is there, right? Having glue, but in that market you can see some tape is there that is very strong. It's very difficult to tear by hand. So there you can see some white line like this will be there, right, over the tape. And after that, if you will twist this one, then that is becomes very strong. Or just take the best example is envelope. If you will take simple paper envelope, then it can easily tear or it can get damaged. But inside paper you can see white color, this type of knit is made with the thread, right? So there you can say that the thread is the fiber and this paper is the matrix. Now once you will add this one, that paper even becomes more stronger. Okay, so in that direction you have to stick that one. The fiber are held in position not only by the matrix but by a removable backing that also prevent the tape from sticking together to a roll. So some even tape, you can see tape will be there. So it's not, if this stick is there, so that should stick on the fiber. But no, they are not sticking in that tape itself. That's why we can use that tape there, so that is preventing that one. The tape is very similar to widely used glass reinforced. Same like glass also we are adding this one, that reinforced material. Similarly, tape also is there. And, okay, very similar to widely used glass reinforced heavy duty package strapping tape. Okay, there we can use. Similarly, pre-pricked clothes or mats are available in which the fibers are interwoven and then pre-impregnated with resin. So pre-impregnated means first add that one, just like what you can say. If suppose something is there, we are polishing that one, and then above that we are putting something. So that is called the pre-impregnated. Okay. So other variations of these principle form of fiber and matrix exist. Other variant hmm, variations on these principal form. So these are, but in that the different also that matrix is exist. Now come to the method, first method. So that is layup method. So this is what we are doing. Three principal layer process for laminated fiber reinforced composite material are winding, laying, and molding. So in layer process, these three methods are there by which we can form a composite. First one is winding. Means suppose some matrix is there, over above that, just wind it. Right? Then also that becomes composite and that becomes a strong. Now laying, put this one, put another layer like that. And also it becomes just like sandwich. Okay, or wafers in that you can see outside wafers is there, inside very small amount of this one is there, that cream is there, and that because of that only that becomes tasty. But if only the wafers upper surface will be there, no one will eat. Right? So here also the strength what increased. And molding at the time of itself melt both things, that is reinforced material and matrix, and then cast depending upon our requirement. Okay, the choice of layer process as well as curing process depends on many factors. So where we will use what are the factors? So yes, first part size, how bigger you want, or how bigger that should be there. What should be the shape of that parts? How much cost should be there? Then schedule when that is required, and all familiarity with particular techniques or not. If suppose you are not familiar with winding, then you cannot. You won't get that much the stronger one. So these factors affects the quality of that one. Winding and laying operation include filament winding. This is it. Okay. Tape laying knot, wrapping, and cloth winding or wrapping. Filament winding consists of passing a fiber through a liquid resin and thin winding it on a mandrel. So mandrel is just like what on which we are winding like this, right? So there, the fiber are wrapped at a different orientation on the mandrel to yield strength and stiffness in many directions. So I already showed you like this. Tape is there, I mean envelope is there. You can see like this. This will be there. Okay, so in many direction that is spread that fiber. Okay, the best example you can see in the envelope. Inside, if you will see, you can see the thread mesh type will be there, and because of that only they're having the strength. And at the same time, here we are sticking after part some small gap is there. There only paper is there. You can see if you will turn that paper easily you can, but inside that is difficult. Okay. Subsequently, the entire assembly, including the mandrel, is cured, after which the mandrel is removed. So after doing that one, remove the mandrel. Now we have what? Winding over that one. If the mandrel is a sand casting, then using a water hose to clean out the new pressure vessel, dissolve the sand casting. It's just apply the water pressure, that will get dissolved, and then you can just remove that. Means that mandrel got removed. Some mandrels are barrel stiff like assembly that must be deassembled through an opening in the new pressure vessel. Barrel STF that cover. So first you have to deassemble it, then only you can remove the barrel. Tape laying start with a tape consisting of fiber in a pre-impregnated form held together by a removable backing material. So whatever is there, that by removing a backing material is required to remove that one. Okay. The tape is unwound and laid down to form the desired shape in the desired orientation of tape layers. So now what happened? just whatever is there, just unwound that one, and then they allow to lay down. And after that, whatever the design direction is required, you can put in that direction. Tape laying can be by hand or automated with an automated tape laying machine. Tape laying can be done by hand also. Just take one or two people, just lay that, just put on the ground or lay that one, okay? Or can be done by the tape laying machine also. Cloth winding or laying begins with pre-impregnated cloth that is unrolled and deposited in the desired form of orientation. So whatever is there in the roll, just unroll that one, then pre-impregnate that one. Okay, and after that, just pre-impregnated means what? They like said in that paper, what is there? That glue is there. They added glue. So in paper, in that matrix, glue is added, that is called the impregnated. And over that glue only we are putting that fiber, that threads, that is the combination, that is fiber. And after that combination of these three, that is what? First paper, then for impregnation glue, and then fiber will make a strong paper. Okay. Seat molding compound SFC consists of randomly oriented chopped fiber. Oriented chopped. Here a space will be there. Oriented chopped fiber in a matrix of resin and fillers. Okay, so seat molding compound is that one. SMC is produced in the continuous manner. So that SMC, that is what? Seat molding compound, can be formed continuously, not a small size. Note that the polyethylene film protects the roller system from getting gummed up with the resin filler paste. So already the paste is there. So what is preventing that one? That is what? Polyethylene film. So just add in between that polyethylene film, and they won't make a stick up with the resin filler paste. The rug-like rolls of SMC are then used in compression molding machine to create large parts such as side of car or trucks. After putting that one, we can put that to make sides of car, trucks, or whatever. That whatever our application is there we can use. Now next is curing method. Curing primarily refers to the process of solidification of polymer matrix material. So curing is what? Just solidify. We had seen one method, it was that by molding. So in that, what I told you, that first we have to heat up to that molten state, and so in molten state, whatever is there, just allow them to solidify, means to become a solid. That process is called the curing of that polymer. Metal matrix material are simply heated and cooled around fiber to solidify. So metal material matrix, but they are just simply heated and then cooled to becomes solid, to solidify. Ceramic matrix and carbon matrix material are either vapor deposited mix with fiber in a slurry and ardent, or in the case of carbon, subjected to repeated liquid infiltration followed by carbonization. So by these methods, we can do curing, means we can solidify that one. Thus, we concentrate here on curing of polymer. So now we will see how to cure polymer. For thermoset matrix material, heat is usually added as a catalyst to speed the natural chemical reaction of polymerization. So catalyst is what? To speed up the reaction. So here, what is a thermoset matrix material? Okay, for that case, heat is just allowed to speed up the reaction. Two-part epoxies, such as found in your local hardware store, consist of a tube or epoxy and a tube of chemical hardener that react when mixed. So then after reacting, that will mix. Heat is not added to a two-part epoxy but is given off as a product of the reaction. So heat is not added, but after the reaction, you can say heat is evolving. So means as a product, heat is that we are getting heat. For virtually all epoxies, volatile gases are given off during curing. For virtually all epoxies, volatile gases are given off during curing. So during curing, what we are doing, that epoxies volatile gases, whatever is there, that we are removing from there. Those volatile gases come from heating the solvent used to keep the epoxy from curing prior to assembly time. In general, the higher temperature during curing, the shorter the cure time. So means what? If higher temperature is there, then shorter will be the cure time. Shorter burning of the material, of course. So if higher temperature means what? Suddenly it will burn. Or if higher temperature will be there, means burning will be fast. Okay, so curing time will be what? Lesser. So now, sort of burning of material. So heat is required, because why heat is required? So just the first, some catalyst and or means one or, that is not just one or two or one only, or that hardeners do not react below a critical temperature. So some are there that is not reacting. So for to make them at the critical temperature, once it will reach the critical temperature, then only it will start reacting. So for that we have to supply the heat. Molecular mobility is necessary for contact of reactive chemical group. So molecular mobility means if molecules is not moving, then also it won't combine. So definitely if this molecule will move here, then only it will combine, or this molecule will come here, then only it will combine. If both will not movable, it's not, you don't have mobility, means this will remain here, this will remain here, no combination or chemical reaction will form. So they must have the mobility, and for that mobility we are providing the heat. Heat drives off volatile from solvent and water, otherwise voids occur. So this heat is removed by water or what? Solvent, so that inside the holes or that cavities, whatever voids are there, that should not occur. So time to time we have to supply the heat. Sorry, do water and solvent. Note that volatile will not outgas if pressure is also being applied. Right? If any pressure is there, then also volatiles will not outgas in that case. And resin flows more easily to obtain uniform distribution. So that's why we are putting even gum, just like resin. So it can evenly distribute or easily distribute. Pressure is required to consolidate or develop the fiber and matrix system and to squeeze out the excess resin. So now what happened? Just one layer is there, put here something, now put resin over here, now put fiber, and then put that one, and then apply pressure from here. After applying the pressure, you can see whatever the excess glue will be there, that will come out. Even in paper also, if you will stick to paper and more glue, if you will put, then after pressing whatever, glue comes out. Right? So to just remove that one, and so you have to fix that, that means to confirm that is fixed properly, a load is applied on that one. Okay, and because of that load or pressure, that excess resin squeezes out. Now, strength and stiffness advantages. One of the most common way of expressing the effectiveness of a strength or stiffness of a material is as the ratio of either of the quantities to the density. So whatever the quantity, just compared to the density. If with that density, if it's more, then we can say that is stiffer, that is weight per unit volume. Such an index does not include the cost to achieve a certain strength or a stiffness. So here that cost does not affect. The thing is how much the ratio of that property to density is greater or lesser. Okay, consider some of the advantages of fiber reinforced composite material. What is that? So first, very high strength and stiffness are about the most common advantages that comes to mind. So for composite, what is that? That becomes very high, so very high strength and stiffness. So for these two, generally that becomes very big. For this one, we get to this. So most of application we require these two. Other properties are also there. We had seen many properties are there, but mostly we are getting by this. Those strength to density and stiffness to density quotient are simply manners of expressing what we call a specific strength and a specific modulus or a specific stiffness. So strength to density, we can say simply instead of a strength to density, we can say that a specific strength, and a stiffness to density as a specific modulus or a specific stiffness, that are particularly attractive when weight sensitive structures such as aircraft or spacecraft are addressed. So means when we are dealing with the spacecraft where the weight matters a lot, right? In that case, we are using these things. Why? Because their density is low and strength is higher. Now, cost advantages and weight advantages. Decreasing the cost of a material per pound of a structure depends on increasing manufacturing experience in a given process and on developing new, more effective manufacturing technologies. Means how we are manufacturing, how much we are manufacturing, what are the things we require. So those are the requirement. For that we have to spend, or that cost is there. So they are all what that 7 types are there. So first one is what? Raw material cost. Without raw material, we cannot buy, right? Then how to design. So whatever the design cost is there, that how much we spend for designing that one, that is the design cost. Then next is the fabrication cost. So for fabricating that one, whatever the cost is there, that is the fabrication cost. Then assembly cost. After fabrication, just assembly. So these are the initial cost. Yes, definitely this should be there. After it's not like that once you manufactured or assembled, that's okay. But what after that operating also is required. So operating cost will be there, like time to time maintenance. Even car bike you are taking that you are going for the maintenance. That is called only that maintenance cost. For operating cost, like fuel is required to operate that one. So that is the cost of fuel is called as the operating cost. And salvage value means by the time after suppose today you purchased a bike, the cost is 50,000. But if you will sell after 1 year, then no one will give you the 50,000. They will give you 40, 30,000 like that. So whatever those 10, 20,000 is there, that is called the salvage value. Means how much loss is there, right? And this overall entire things is called life cycle cost. Okay, so this is the life cycle cost of any composite or any material. Weight advantages. Okay, now so weight advantages. What is that? What are the benefits of saving weight in the structure? Right. So what are the benefits? That if we will weight save the structure, then we can increase the payload or we can utilize those weight for some other things. Generally, we can choose from several alternatives. What? First, we can directly transfer weight saving into saving of fuel, so that more efficient operation condition result. Means once we will save the weight, means we can take more fuel. Okay, so more convenient or that easily that operation will be there. Or else we can carry a heavier load of fuel and increase the range of aircraft, or some combination of two is possible. So either just carry heavier load of fuel and increase the range of the aircraft. So both, either increase the range of the aircraft and take heavier load of the fuel. Means more you have to just take more fuel, then only the range will be higher. Or next, some combination of the two is possible. Further consequences of decreased weight of an airplane are that engine thrust, wing area, and fuel can then be decreased. So consequences will be what? If weight will be higher, means we have to reduce the fuel weight, or that engine thrust will get reduced, or what wing area we have to reduce, and fuel. So these are the consequences of decreasing the weight of the aircraft if that is not that much strength. Okay, so in this what we had seen, right? So see again initial form of constituent, whatever the things are required, then for before manufacturing the composites, then first layup method. In that layup also the three different methods were there, right? Then curing, then strength and stiffness advantages, then cost advantages. These are right. So in cure layup method also we are seeing what three are there: winding, laying, and molding. So by these methods we can that layup method or we can form the composite. So in winding what happened? Just over the matrix or anything we are winding the fiber. Okay, laying means over this one or in the one constituent material, the other constituent material is like just laying over to that material. Okay, and next molding, just take both the material, go for the molten level, that means apply heat, and then that will be distributed evenly. Then you can say that the composite form. Okay, then curing method. Curing method is simply just it's a solidification of whatever, just like in molding. At higher temperature, that will be in the molten state. So after that, make it to solid. That is called the curing. Next, the stiffness and that strength and stiffness is one. What are the advantages to if strength will be more and stiffness will be more? Means if strength will be more, we can reduce the weight. Okay, and for reducing the weight, we can utilize that amount of weight by keeping or taking other things, like we can take more fuel, more luggage, or anything. So once aircraft weight will be lesser, then only and more strength, then we can carry or we can take more fuel or more payloads. So that's why strength is very. Now stiffness, what happened once we have the composite? So depending upon the structure, how many times like suppose this one is there, or aircraft is flying. So instead of one or two operation, that will chances are there it will get played. But if that having a higher stiffness, even it will bend slightly because of some gust or something, then also it will come back to the original position. So that's why stiffness also is very important. So once these two are improved, this what that becomes better than the existing one. Okay, so now cost advantages is what raw material cost, design cost, fabrication cost, assembly cost, operating cost, maintenance cost, salvage cost. So these costs are there in that. From here to assembly cost is the initial cost, then operating cost, how much you will operate, according to that you have to pay. Then maintenance, for that maintenance also you have to make the maintenance, for that you have to pay. And salvage means the price reduced. Okay, then these are the advantages of the having lesser weight. If lesser weight will be there, we can take more other things. If weight will be higher, then we cannot take the other things. Okay, so if you have any doubt, you can just comment on the video. Okay, or you can contact me for your doubts. My contact number is given, that contact details is given, so you can directly contact, or you can just comment in the video. I will comment you the solution of your doubts, or directly you can contact. Okay, so thank you.
Like, share and subscribe. Hit the bell icon for more updates.